Right. So, well, not the best transition in the world, but here we are. Good morning from Ann Arbor in Michigan in the US. And we are going to get started. So, welcome everybody. We're going to start with the third office hour. In the XR MOOC as part of a series of office hours I've done this semester. And this is the last one that I have planned for this semester. The semester ends at the end of April for me. So what I'll do is I first go over a few steps and guidelines. And I think I narrowed it down a little bit. I didn't do so much on the HoloLens this time. I suspect that not a lot of learners have access to it. I can always do a special on the HoloLens if there is interest. We'll focus on mobile AR using marker-based AR with Vuforia in Unity and using AR Foundation, markerless AR, so just running around with our phone. That's the focus of this office hour. And I'll go through the assignments quickly in the honors track. And then we'll stop recording actually, and we'll answer any questions from learners and have a bit of a discussion. For that last part, when we're not recording, it would be awesome to get to meet some of you. And if you were then willing to share your audio and video, that would be really great. So we'll stop recording for that last part. So let's get started with the office hour. So I have put together, this is the third video in a series where I've gone through assignments in the honors track of what is the last course in the XR MOOC specialization, extended reality for everybody on Coursera at the moment. And so each of the courses has an honors track that usually spans 3 out of the 4 weeks. In the third course, we get an overview of development approaches, and I'll let you choose which of the tools you want to use. A-Frame for WebXR, Unity and Unreal Engine are the 3 tools that I discuss. I could do more in-depth content on each of these. This is actually one of the things that learners wanted the most. The philosophy that I had when I created the courses, I was afraid they would be outdated too quickly if I showed too much in Unity or in Unreal Engine doesn't move as quickly. WebXR is also relatively quickly evolving. And so I was hesitant to do a lot of hands-on programming stuff in there, but I realized that there is a need from learners, so I wanted to do these office hours, and that's what I'll focus on in some of these. Here we're going to focus on the assignments. I'm not here to teach. I'm just going to be here to give tips on the assignments and how to approach them. So this is the third one, as I said. We focus on AR with Unity today, and it's just mobile AR. You might be owning other devices that can do AR, Unreal, or Magic Leap if you have that. I happen to have, as I said, the HoloLens 1 and 2, but these are fairly expensive devices and actually still a little bit exceptional to have access to them. So as usual, we have to deal with Unity version management. So the version that I've been using for my examples here is 2023 26 F1, and there's already, I think there have been at least 2 updates since then in Unity. As long as the first part, so 2023 is the same, I wouldn't expect major differences. When it jumps to 2024, or when you go into the pre-releases under 2021, Unity starts to look a little different, and then I cannot guarantee that the stuff here is still valid and will still work the same. There have always been major changes to Unity. Over the last 5 years that I've been teaching, I had to relearn every semester how to do it in Unity. It's always been different. One year Vuforia was included and was excluded. You had to set it up. Now you have to download it through some special kind of, well, actually their own PTC website. And so, yeah, it's been interesting. When you prepare your Unity, you should get Visual Studio, and then you should get whatever platform you're developing for. So the biggest problem I have with these assignments is when you want to do marker-less AR, so with a smartphone, for example, you really need to be able to deploy it to the phone. There is no good preview Yes, I know there are device simulators and whatnot, but there is no good preview, so you need to deploy. And in order to deploy, you need to install the right stuff. So for if you are an iOS user, so you have an iPhone or an iPad, you need to have a Mac computer, a MacBook or an iMac, in order to develop for them. There's no way to do it with a Windows computer, as far as I know, and we always run into these issues with students. So the worst constellation is you have an Android phone. You have that's the worst constellation is you have an iPhone and a Windows computer. Then there's actually not much you can do with it. And I usually loan Android phones to my students. So when you're in the XR space right now, Apple is still doing their own thing, and they will come out big one day, I guess. But for now, it's not a good device to have, not a good infrastructure to have for development. Unless you really want to specifically target ARKit. So you would get the iOS build support in that case. But for me, since I'm working with a Windows computer and Android device, a Pixel 5, I get the whole Android build support. That includes the Android SDK, the software development kit, that I can actually develop for Android, and the OpenJDK, because this is Java based, so I can actually compile and deploy, so build and deploy to a phone. All right, and then as you've seen maybe in previous office hours, there is a video playlist. So what I'm not going to cover is basics in Unity now, how to click through in Unity. There are videos in the YouTube playlist. I'm going to jump ahead quickly in the presentation to share the link to that playlist. It is also part of the MOOC content that I created. I created a new page in just before the honors track is starting, really in the third course, and there I linked 2 of the previous videos. I shared the playlist link just with you if you want. There is additional content in there. The first office hour is in there. Then the first office hour focused on A-frame, so I have videos that focus on A-frame, also build a little bit of a solar system, a second version in A-frame. I continue doing my solar system because that's what I've been doing in the second course. You could do other things, obviously. I don't just do solar systems, but they're pretty cool. It's relatively easy shapes to work with, and interesting how to animate things and work with lighting, although I didn't get the lighting right. I think then the second office hour was focused on virtual reality with Unity. And so I have how to install the hub, create a new project in there, which is not always the same. So today we use a different template, but usually I say start from the 3D template. And then I went through creating different kinds of environments for Unity. And then I have one important video on testing and deploying with a Quest. And the Quest is also an Android device, an Android-based device. So it's a virtual reality headset, the Quest 2 that I've been using in the second office hour. And now the third office hour, we'll insert a video just here from this video that I'm creating right now. Will go just between here, and then I have 2 more videos on doing marker-based AR with Vuforia and markerless AR with AR Foundation for my solar system. And these are not edited videos, they are real time. That's why, for example, this one is 35 minutes long. I think I was creating some of these videos in the context of my residential course, and may have told some stories while I was waiting for things. So we'll go back up here. So the biggest thing is you have essentially two big choices when it comes to augmented reality with Unity. You can do marker-based AR. In this case, I use standard Vuforia markers like this astronaut marker here. Vuforia is an industry standard leading kind of package that a lot of augmented reality pre-ARKit and ARCore was all Vuforia and AR toolkit. There's another library from Austria, Wikitude. There's Eighth Wall. So there are a lot of, and some of these are behind a paywall. So and subscription based. But Vuforia is while it is an enterprise software, it can be used for free in educational settings. So we'll use Vuforia. And then for markerless AR, what I would always recommend with Unity is, as much as possible, is use AR Foundation. AR Foundation is their abstraction which implements principles of ARKit and AR Core. So in theory, and actually in practice as well, so we've done this for my courses, we have sometimes created starter projects for the students, and a lot of my students use iOS devices, and then actually a smaller number of students use Android devices. With AR Foundation, you can create one AR project for your phone and deploy it according to whatever platform you have. So you can switch a few knobs, and then it'll be an ARKit project, can run on an iPhone or iPad. And so that's why AR Foundation is good. You can also work directly with ARKit and AR Core SDKs. I haven't done this in years. The ARKit plugin used to be hosted on some Git repository. I don't know what it's like now. The only reason you would want to do this is if you want to have access to the very latest features. Let's say there's an AR Core version coming out or an ARKit version coming out. A few years ago, it was about face tracking, more than 400 points of face tracking, or login, and that are features that are really just specific to ARKit at the time, and then AR Core did the same. And so AR Foundation was behind. But for most common things, you would use just AR Foundation. And then on top of it, as an option, you could use XR Interaction Toolkit or Mixed Reality Toolkit, which I've talked about. Mixed Reality Toolkit I've talked about last time. XR Interaction Toolkit, I'll extend this a bit. What it'll allow you is to place content, move content, rotate content using basic gestures on the phone. And I'll just very quickly go over it. I don't actually have a specific video on that, but I could create another video if that's necessary. Then I wanted to say one last thing you could also do is use AR Foundation has image targets. So I could make this an image target, which is actually a Vuforia marker. I could train AR Foundation, which is Unity, not PTC Vuforia. But it requires a marker-less approach. So even without a marker, you can use markers. Even with a marker-less approach, you can use markers. Sometimes this can be done. But the AR Foundation image targets only work on your phone if your phone supports ARKit and AR Core. The good thing about Vuforia is I can do it with a webcam. So what I do in my courses and what I show today is I'll just simulate like a webcam. Most students have a laptop or a camera, or I happen to have this one that I can move around, just a $30 webcam here. And that's why marker-based AR is actually still really, really important, at least for prototyping. And also when you want to develop things at scale, like for a classroom where not every student has access to the latest device. So these are our options. And let's look into the course 3. So we'll focus on the AR scene I said, but first I'll quickly review what we actually want to create today. So the 3D scene is the first week assignment, and the idea is that you build the foundation for both your VR and AR scenes. So the whole honors track is essentially creating three scenes. The first one is the 3D scene. And I had something focused on that before. So as a quick reminder, I'm doing the solar system. I'm inspired by the NASA solar system exploration thingy. I'll just give you the link so you have something to play with while I'm showing this. It's pretty cool. It's interactive. You can zoom in, look around. You can find Earth. You can double click Earth, for example. One click gives you some information, double click zooms it in, and it is obviously what I'm going to create is not going to be as good as what NASA does. So just set expectations here. But I was inspired by this, and so we're going to start this. So what I like is that you can explore it. You can go to the sun. You can get some information about the sun. And you can also go to Earth, and obviously these objects are in relation to each other. So the moon is relative to the Earth. So the
interactions are interesting. So your slide.
Okay, sorry. And I hope I'm not sharing sound at the moment, but we're gonna actually do optimize for video. So in the second course, my second course is focused on interaction design, user experience design, and interaction design. And I go over the principles of all the things that I think you should do before you start developing. In the third course, I have a reminder that some of these techniques that I introduced in the second course, you're, for example, working with a 360 grid in accurate angular format to plan out a whole scene around the user and sketch it out in if you will, in 360, and then preview it on cardboard or in a 360 viewer. So these, I think, are all still valid and important approaches. They allow you to pin down the design concept and explore interactions quickly. I would never recommend, well, if you're really good in Unity, I mean, you can probably iterate relatively quickly, but there's a big difference between me sketching out new different kinds of versions of my content in an immersive authoring tool like Tilt Brush here, and just exploring alternative designs while I'm actually in VR. And then there's a big difference to actually implementing this in Unity as well. But if I had to iterate and change the interaction design, discuss with the client or whatnot, and do everything in Unity, you really have to be really, really good in Unity. It's most likely too expensive, and it's better to do it at the earlier stages. So I will just implement the concept that I explored earlier, basically the concept that I explored in the second course. I'm going to just go here. So it was based on one of my storyboards. So I want to be able to place the content if necessary. And it could also be with a marker. And I would see the sun, and then I would have, I had a couple of ideas with nights and a night version. So looking at the day and night of the Earth. And I talked more about this in the second office hour, how to do this and what I got right and what I didn't get right. But what I really want to do now is I want to have the sun, and maybe we don't look inside the sun. So I gave up on that idea. It was based on an original Google Expeditions solar system that I wanted to redesign. Is actually one of the assignments in the second course. And then I want to have Earth rotate around the sun, and then the moon rotate around Earth. So that's all I want to do. I created a solar system in Unity. And then in the second office hour, I talked about all these different kinds of steps required to build the solar system. So you can see I start from primitives. You see this in the background, it's just white spheres. And then I actually texture them and add materials. And then I add, I change the materials a little bit, like how light is reflected. And I also changed the background from the standard Unity background to the black, kind of like background. And so the way this looks in Unity, oops, none of my projects are, oh, they should be open here, 1 second. So the way it looks in Unity right now is like this. So this is my 3D scene. I have this composition here. On the right, you can see I have a sun, the Earth is nested, and the moon is nested inside Earth. And I have a little rotate script for each of these objects. And so what will happen when I play this is that you will have the sun in the background at a certain distance, and the Earth will rotate around the sun, has its own rotation, and the moon will rotate around Earth, and the moon also has its own rotation. So these are the things I created. Not too crazy, but it fulfills the assignment requirements. So we're going to focus on the AR scene now. So how do we get this into AR? So we have marker-based and markerless AR. The assignment says create an AR scene in Unity, add the AR module or plugin. So what we do is we just start from what they call the AR template, and we get all this. I'll show you that. Then we actually, what we'll do is we'll import from my 3D scene, because I created a new scene. So I'll export from that old 3D scene in my video. I export the constellation of my solar system with the materials and the script, and then I'll import it into my new AR project. So it's one way of adapting the 3D scene. You could also really take the 3D scene and add the XR rig for VR, and then take the 3D scene and add AR Foundation over Fourier. But I wouldn't recommend adding all these different packages into the same project. So that's what I usually do. What I usually do is I start a separate project, and then if I need to reuse any content between the projects, I'll use the asset management in Unity to creating prefabs via drag and drop, and I show all that in the videos. And then our goal is to make it blend more with the environment using light and sound. So what I focused on is actually scale. I had to do a lot with scale. The things were too small and too big. I didn't pay more attention to lighting. I do think it would have been good to actually do that. And I didn't actually add any sound, but sound would also be interesting. I mean, my solar system, there's not a lot of sound going on, but I've done the zoo, for example, and there would have been nice to actually add sound to some of the animals. And then there's an optional piece to make things interactable, and I'll talk about that. And then I would also encourage learners to try out, if you did marker-based, to try out markerless. So these are the steps. And when you look at this, you might think this is a lot of work. It's a lot of tasks, but I mean, from a VR and AR development perspective, these are foundational things. So you would learn a lot if you did them. And if you don't have to learn Unity from scratch, I think you can do this in an hour. So my students, but the reality is you always run into issues. So I guess it's more likely that you'll need 2 to 3 hours. But if you just follow my my videos, you should be able to be successful in less than an hour. But then you would probably just have the solar system. So let's start with the first part. We're going to do a marker-based AR version of our solar system with Vuforia. So we're going to get started with the 3D template, and then we're going to get Vuforia engine into our project. And there's a longer video that shows all these steps in detail in the playlist, but I'll just it's 30 minutes or so long, or maybe 20, I don't know. So I'm not going to do all of this live here, but I just want to walk you through the principles, and then you can watch that video if you really want to do it. So you get Vuforia engine, and I'll show you how to get the license and all that. And you can also get some of their samples. The samples would give you the image database that they have here with some of these markers, and I think maybe I printed some inside as well. So there's like 4 markers. I mean, you can't really see them, just like, you don't actually have to look at the details, but it's just like paper-based markers that I'm using. I'm going to use the astronaut. And then you have 2 options with marker-based AR. You can use a webcam, as I said, which is very good. You just press the play button in Unity. You do not have to deploy to a phone. You can always deploy to your phone and then use the phone in combination with the marker. But that process is something I'll show only in the second part. So there is a video in the playlist on marker-based AR with Vuforia. It really goes over, okay, it took me 17 minutes to get the samples to work and explain everything. So this is something you can play with. And so I have the project here. I'm going to actually do it live. Let me see what else. Yeah, I would have explained how to. Let me quickly go through the steps. So and then I'll show you and run it, and then we can see it. So it's the way you get Vuforia into Unity changes from time to time. So what I usually share is the getting started with Vuforia engine link. If you Google for Unity Vuforia, pay attention that you're using the latest version of the engine. So when you just Google it, you may not end up, see, it's 10.5 now. You may just end up at engine 9.8 because that's what happened when I Googled. And then there was warning there, like getting started, it said like, this is not the latest version. So they recommend migrating. If you see this box here, I would recommend going to the latest version of Vuforia engine. And so there are ways to actually get it working with Vuforia engine in Unity and actually setting up everything. And they also have quite a bit of tutorials on their website. And the samples that I recommended are just like, they have a bunch of sample scenes in there that you could actually try out on your phone. And I often make this the first assignment in my residential courses so that students can actually see whether they get the samples to work. And one of the samples that I can just like show quickly here is this one. So I'm gonna gonna put some of these things on the side. So let me see, this is my AR project, which is the markerless version. I should probably name them a little bit better. And I'm gonna open one more project in the background. I haven't opened that here, which is my Vuforia project. Okay, let's get that open. And then I can run it for you and show you what I did. So Vuforia engine, so you would follow the steps, but essentially it takes you to a download after you're logged in, and a registration is for free, and you get a Unity package that you need to download. And when you have that, you can then also import their samples. That's something that you should find relatively easily. And then you would actually, if you wanted to manually create a new scene, you would create, so their sample scene is empty, but you can look at the image targets, how it's set up. So essentially creating a new Vuforia, so webcam-based enabled scene, you would insert the AR camera. So you have the AR camera in here. You get an image target, which is the astronaut. And you do this by choosing from database and the Vuforia Mars images. That's how you do it. And then you can place an object on top. So the sphere is on top of the image target. It's like nested and really scaled down. These image targets are very small. And then you really need to scale things down. And so the size works in an interesting way. Size is relative to the marker. So it's not like 5 meters is a unit of 5 in Unity. It really depends on the marker. It would actually be 5 times the size of the marker. So the marker is the unit because it doesn't actually have any environmental understanding. It just uses the marker to judge distance. It's like a $1 note that this engine was trained on, and you can have different markers, so that can have custom markers. And then we can have a little astronaut standing on this. So I'll show you what this looks in Unity when you actually have it running. So here, I'm gonna get my Vuforia project. I have, I guess, the solar system here. This is the final version, but I'll have a cube first, just as a proof of concept. So I've set it up everything the way it was a sphere before, but now it's a cube. So I press play and I use my webcam here, and I'll optimize for video in a second. So it is optimized for video, okay. So and here we have the cube on our marker. I can rotate this marker. In fact, I can actually lift it, move it. So tracking is really robust. And I can occlude part of the marker. Then it's harder for it to track, obviously, and it'll snap back. But if I occlude just part of the marker, not like I'm not sure what the percentage is, maybe 25 to 50%, I can still occlude and it still works. So oftentimes you may accidentally hold things like that. I usually print markers with more of a white border, or like something I can hold on to so I don't occlude the marker when I touch it. And anyway, so this is our first example. And then when you feel like, wow, this is success. So there's a number of steps that I had to pay attention to. Most notably is when you configure the AR camera, you should open Vuforia engine configuration. So again, I show all this in detail in my video. But I show how to get this license key in here, which is for free. And then the most important thing is it may per default be configured like recording. So what happens then is, even though you have a webcam attached to it, I guess, hang on, and now it complains about the license key, which is weird. So let me just remove that for a second. I hope I didn't kill anything. And then you feel like, oh, I'm using my webcam, but it's actually playing a video. It's playing one of their videos. And so what you need to pay attention to is that you actually have a webcam selected here, and then choose the right webcam, whichever. I have a couple of cameras usually connected. And when I play now and without the license key, it'll have a little bit of a watermark, which is not the worst. So even without the license key, it would still kind of like work. But I'll bring my license key back in there for engine configuration. License key. Once it's pasted back in there, it should. Oh, now it's complaining. I don't know what I did. I hope the engine key is invalid now, so I'm not sure what happened there. So I may have a problem. So in worst case, I can run it without the engine. I thought I just showed it before and it was working. In any case, we're going to go to our actual scene that we want to create, which is we want to bring back the solar system. So one thing you can also do is open one of their samples. So it comes with a lot of samples, and the one that I usually like to show is the image targets one. I also have videos on that, and as a proof of concept, and I hope it doesn't. Okay, it's still going to come give me this. So let me just remove the license. I am not sure what exactly I did with the license. Oops, no, I'm clicking the wrong things. One sec. Download new version. I don't want to have the latest version of Euphoria. Somehow my license key is not active anymore. And it was just active until I started this. Anyway, let's do it without a license. It's still fine. Just a little bit of a watermark there. Here we have our astronaut. Actually, they are astronaut. And then this is one of their examples. And then you can also have like multiple markers next to each other. So here we have the astronaut and the oxygen thing next to each other. So it supports multi-marker tracking also, and that's a pretty cool example. And it has a nice 3D model. What's really interesting is like how small these things are scaled. So it's 15% of what you would normally use at 1:1 scale. So you really scale everything relative to the marker. So just look at the scene and think about how big should the content appear on top of the marker. And the marker that I printed out is just like their standard size marker. It's not too big. It's like it's maybe like 12 centimeters or something. And then this astronaut will be standing on top of it. And it's almost like it is in the preview in Unity. So let's do our solar system just as a proof of concept. So I have another scene here. So in my videos, I explain how to get the content from the 3D assignment into the scene. What I've done is I have packaged it up and then I imported the Unity package. I got my script and my prefab. So the prefab is the sun and the script is the rotate script. And then I put it inside the image target. Here's my prefab and the whole composition. Then I scaled it down like crazy. You will see how I scaled it down like crazy because it was just too big and I would never have been able to see the sun above the marker. And so I scaled it down. And then what I did is actually I changed the proportions. I actually scaled the Earth up because it was so tiny, and the moon relative with the Earth, I scaled it up. And then I also changed the way things rotate. I actually have them rotate a lot faster because these are now really, really small objects, a lot faster than I had it in the previous VR version. So these are some of the biggest changes that I had to make. And now when I run it, and it's probably not gonna yell at me because I removed the Euphoria engine configuration. So I just use this marker here, and there it is. And we have our solar system. And you can see how I'm trying to hold it a little bit stable. You can see how the Earth, hang on. So everything will be obviously inserted, will be rendered on top. So there's no occlusion or anything like that. But here is the Earth and there's the moon, and they rotate around each other and both rotate around the sun. So that is, it's pretty cool. And then you can go closer and like look at things this way. Keep in mind that I just lost tracking of the marker, but it still kind of worked. And the tracking will change at the bottom of the screen. It'll tell you extended tracking. You can see this down here. Oops. down here, extended tracking. What that means is it actually can't track the marker anymore. Now it says track the astronaut marker. And now I actually have a little bit of a performance issue. So 1 second, I'm going to restart this one more time. Sometimes I have to plug in the camera one more time, and it'll be fine. I realize the streaming speed is probably not ideal for you. But okay, so here we have them. And then what I wanted to show, you can actually go relatively close to them. But at some point, when you go too close, what I'm doing with my camera, I'm going close to the content here. When you're going too close, you will start clipping through these objects. So it's like when the user holds the phone, it feels awkward with a webcam, but when the user holds the phone and goes too close to the content and you do not render them from the inside, I do not render these spheres from the inside. I didn't actually model anything inside Earth. So it's just empty and it just starts clipping through it. And it would look different if you had objects that had interior design, like a house or something. You could actually go into the buildings and render them from the inside. But in my case, these are just one-sided rendered spheres. That's why it looks so weird when you start clipping them. So going too close to the content. So this is marker-based AR. And again, I went over some of the steps quite quickly, but you can follow them in the playlist. What I would recommend is that you can show the marker on another screen if you want. In fact, I could like run it like this, actually use the webcam, look at the screen here, and but I would just print them out. I think there's a benefit if you have access to a printer to print them out. I think it needs to be in color, and the templates you can find on the Wuforia website. Cool, we had this working. So now I want to show the second solution, and then we're going to jump into questions after that and anything about the MOOC. So for the questions, there are no rules. We can talk about anything, any advice, any questions, any tips. So the second part is doing this whole thing marker-less with AR Foundation. So this, as I said, requires a couple of different things. So first of all, we would start from the AR template. Yes, the first time we're starting from an AR template. So I used in the second MOOC, I talked about doing virtual reality with Unity. And I said, do not start from the VR template, start from the 3D template. But in this case, we actually, and the same actually for Wuforia, you would start from the 3D template and not the AR template, because the AR template is really marker-less AR. Sorry, here, this is wrong. My the title slide should be marker-less AR project setup. I'm sorry about that. So we're using AR Foundation, as I explained, as an abstraction from ARKit and ARCore. And then optionally, for interactions, you could use XR Interaction Toolkit or Mixed Reality Toolkit. So Mixed Reality Toolkit is something I've talked about last office hour. Mixed Reality Toolkit was originally designed for the HoloLens as Holo Toolkit, and it became Mixed Reality Toolkit, and now it's when it was primarily Windows virtual reality devices. So the Windows Mixed Reality headsets, which I have one down there, is like the Acer Blue one, for example. And then, so they opened it up to VR. And now they actually also support markerless AR with AR Foundation using, so on the ARCore and ARKit, you can also use MRTK. And what MRTK gives you is good interactions and widgets that you, like menus and checkboxes and radio buttons if you wanted to do that, which I would not recommend in AR, but you could do that. And I would also not recommend it in VR, but you have access to these widgets. So, and then the option that we don't have anymore is actually just previewing it with a marker. So you could have a Wuforia project to try out your AR content relative to a marker, and then you would, okay, now we want to do it without the marker. We actually want to place the content somewhere in the world. Maybe we want to augment this TV or build something around the TV, like a cool AR interface around the TV. And then you would actually switch to markerless AR, allow the user maybe to place the content relative to the TV, and then you would have to deploy. But the majority of the interactions and the content design and all that could be done using the previous techniques, marker-based AR relative to the marker. So you can just use your webcam and play around with it and simulate things, and then actually do the final step when you actually want to create a marker-less version of it and you deploy it to the phone. So ARCore and ARKit are actually widely available on a lot of different kinds of devices. For ARKit, it's relatively straightforward. It is some kind of iPhone 6 and then iPhone SE or anything higher than that would support it. And then there might be minor differences in terms of some of the things that are not fully supported. So it's worth checking out features that way. And for ARCore, it would mean, so basically, obviously, all Google devices would be supported, requires Android 8.1 or higher. And then there should be a list of device models. So like it's actually quite a long list as well. A lot of them are Google phones, but Huawei phones are supported, and a lot of phones I don't actually know, LG, Lenovo. So a lot of different kinds of phones are supported. And sometimes it doesn't support all the features. So it is interesting that AR Foundation has, because it's an abstraction of ARCore and ARKit, so works across these, it actually also supports Magic Leap and HoloLens, as they say. And so there's a number of features that you can check whether it is supported or not. So motion tracking, or what they call device tracking, so like 6 degrees of freedom, not just orientation, but also position, including Z, is supported using visual inertial odometry. So the idea of using the IMU in here, the inertial measurement unit, and the camera tracking. Supports plane detection, point clouds, anchors, which is anchoring things to objects, light estimation, and then lighting, which is actually their ideas of what environment probes are, like essentially trying to build an understanding of their environment and creating a environment map of it and applying it back to an object, so it looks like it's reflecting part of the environment. So there are some examples for that. Face tracking, which I don't really pay too much attention to, and then 2D image tracking, which would be, we could use the the Fourier markers with AR Foundation. We could do that, but you could use your own markers as well. There are actually specific tools in AR Foundation. There's an image training tool, I think it's called. Forgot. It's a command line based tool that gives you feedback on the images that you provide, and you can train your markers on it. We have used this some recently actually in an assignment. So a lot of features, and then because so it's interesting, AR Foundation also supports what they call pass-through video. I only know pass-through video as this idea of a quest. Where's my quest? Yeah. The quest can now give you what is called pass-through. So you use the double tap, you would see the environment around it. Oculus is making progress to turn this more or less, or Meta, to turn this more or less into a device that you can use for at least prototyping AR applications, even though it's a VR device, by giving you access to the outward facing cameras, which are actually grayscale at the moment, but very easily, you could very easily imagine that future versions of the Quest would have colored outward facing cameras, and then you could support pass-through. And then occlusion is the idea of, for example, detecting that there's a hand in front or behind the virtual content, and we would occlude it accordingly. So we need to detect the shape. So ARKit has people segmentation. Do they list it here? People, I don't see that right now. So human segmentation, here they call it human segmentation. It only works on ARKit. It's actually pretty cool. It can detect a human skeleton similar to a Kinect in real time, and not just the skeleton, but actually the shape of the user, and then actually segment them out of the video and do occlusion rendering. I've shown several videos of that in my foundational courses in the first course. So let's focus on the project. So now we're going to do the AR template. I need 3 more minutes for this because I'm not going to actually run it now. We're just going to point you to the video. So we start from the AR template. We go create a new project. We call it my new AR project. and we choose the AIR template. The AIR template essentially gives you a couple of things. So it brings in AR Foundation, it brings in AR Core and AR Kit, and then as an add-on, I could enable preview packages and then get XR Interaction Toolkit installed if I wanted to do that instead of MRTK. I'll explain that, but this last step is optional. The first thing you do is after you don't actually have to do any of this. This was just showing you when you start from the 3D template, this is what you need to do. If you want to start from if you start from the AIR template, if you want to start from the 3D template for whatever reason, then you would have to install all these packages and set this all up. But let's say we start from the AIR template, we get all this for free, but we need to get XR Interaction Toolkit if we wanted to have some XR interactions with placement. And in order to see that, you would need to enable preview packages. Then the first thing that you do is you just enable AR Core under Android. I don't have screenshots for how to do this with iOS, but if you were on iOS, you would have to remove the Vulkan API. You will see error messages, and you may need to remove this. Actually, right now, it's the way it was set up for me. It worked perfectly. I didn't have any issues. I just clicked this thing after I used the AR template, and I didn't even have to pay attention to any of the Android versions, but it would need to be probably Android 8.1 now, is what I just saw in the documentation. And then we can run it. So I have this video here that actually goes in 10 minutes over all the steps. It creates the new template. It takes the content out of the 3D project, brings it into our new project with the template where I explain what each of these packages are that come with the template. Then we could bring a cube in there, and I would explain now, actually the dimensions now mean 111 means 1 meter by 1 meter by 1 meter. Now we have accurate dimensions. And so pay attention to that. So my solar system was 109. The sun was at dimension XYZ 109. That would have been 109 meters. So I don't think I would ever have been able to see this. And so I recommend scaling things down, and that's what I do. And then I'll actually bring in my content, import it, I position it relative to what is the AR camera inside the session origin here. And then at the end of the video, I'll deploy it. And this takes the longest. So for that, I go to the build settings, I switch the platform to Android. I have my phone already in developer mode and connected. There's a lot of things that could go wrong with USB. So looking up in Unity how to deploy projects to a mobile phone, there is documentation on that and a lot of troubleshooting. And then finally, I'll actually run it on the phone. It'll look like this. This is our marker-less version. What is cool here, I'm just gonna optimize for video. It's the last thing I show. We don't have to pay attention to keeping anything in view. We can just like freely walk around, and we can look at the moon in detail, and the sun is and then the sun and the earth are rotating, and we can take our position relative to the content. I wasn't exactly happy where it appeared. It was supposed to be 60 centimeters high. At least it's, but you see where my plane is. My floor plane in the video is actually not at the floor level. It's actually higher. It is relative to where you start the phone. Where you have the phone, it's probably 0.6 down or something. So I haven't figured, because I didn't actually implement plane. Well, it does have plane detection because I'm using AR Foundation, but I would need to use hit testing and then allow a user to place this. So if there are additional things and learners want me to expand more on this, I can always do that. I teach a lot of these things in my residential course, but it's very hard to maintain and keep up to date with the rapid pace, as I said, with which Unity, Vuforia, and AR Foundation and all these things are evolving. So that's why I've been hesitating a little bit. So I wanted to just end by saying, so if you wanted to go further, you could get the XR Interaction Toolkit set up. It's actually Unity XR interactions, you could use an AR gesture interactor, and you would configure things so that it's basically just following the documentation. And at the default plane, which is actually set up for you, it's already visualized using this feathers, kind of like these little bubbles you could see to where the plane is detected. Well, the floor is detected, the floor plane, but you would actually then see an actual plane detected. And you can use the AR raycast manager. It's actually just following the tutorials on that and put an AR placement interactable in the scene. And what you would get is, once you have this interactable configured so that you can drag, scale, and rotate, you will have a plane detected. This is the plane that's detected here. And then you will have the object there that is placed upon hit testing. So this, now we have the plane there. We do hit testing. So we find out from the finger into the 3D world, where are we touching this plane, the intersection point. This is where we place the object. It's an interesting view, the way we recorded this top down. And so normally you would hold the phone at an angle. And so this is AR Foundation with XR Interaction Toolkit. I should probably change this plus XRI. So I will stop my official part here, and we will stop recording